combine just normal one and the look at together, and then we're going to create some kind of animations. Okay? Fine. So the first one, okay, they find some location randomly, all right, and the second one is always chasing something. Okay, so we're gonna put one of the moving ball in the scene, okay, and then the second one always chasing or look at that ball. So this one is first one and this one is the second one, right? So let's change the second. The one is look at. Okay, look at. Look at. I'm gonna save this one another name. Okay. Look at. So what do we have to do first? We're gonna create a sphere motion sphere, and then to make the sphere wandering around the space. So in order to make that things happen, we need sphere. Yep. Sphere dx9, sorry, sphere geometry. Alright, sphere geometry. Yep. And then what else we need is we need a renderer and point fraction 1, and then connecting to here. And we need transform to move the ball. So to create the wandering things, we're going to use the Cartesian 3D to vector. So do you guys remember what Cartesian do? Yep. They, if you provide information, pitching and yaw, and the length, okay, they converting into the x, y, z value. So we can use this value and connecting to here and to here and here, right? So let's create the random spread. Okay, random spread, and also we need another random. And random array4, and connecting to the change to the random, and change the random integer number, yes, and the range is 3000, and connecting this pin into random seed, and we're gonna have the two random spread. And if you wanted to move the ball wandering just around that, the top sphere, okay, top sphere, what you have to do is, if they have the negative value, they're gonna move underneath sometimes, yep, underneath. So we can tossing that to the positive value, and then we can install you can put the Newton or damper, whatever you want. I'm going to use the damper. So connecting the damper value here. And then damper value needs to be spread too. So vector to the split. So x, this one is going to be there, and this one is going to be there. And this one is actually the length. So if you wanted to give, the consistent length, you can just provide the information here. Or if you want to give, like, the random length, you can connect in this value here. So it's up to you. So I'm gonna use that consistency value. And then what we have to do is vector 3D joint, and together connecting to x and connecting to y and z, and put it into coordinate. Okay. So now what we have to do is we need to create another pin port renderer or group. Connecting this pin to here. So now you can see that ball is moving around. Okay. Yep. So, and then if you provide this information, this one to look at, you can see that they're looking at this ball. It's not so difficult, yes. And if you change the value to the damper is 5 seconds, it will very slowly chasing around. Yep. And also I'm going to create another motion in here. So delete this one. And another area plotings and random spread, and this time is 3 different numbers, and ABS, and connecting to that, and the split into the vector. And we can connect in this pin in here, and here, and here, and here. So now it's big. So we can add damper. Okay. So it looks like that it has some kind of character. Here. Okay, so let's make another little bit more. Pure itself. Good. So what we can do with this? What we can do with this? What we can do. Okay. So that is one way we can create the animation things, and then you can change the shape. Instead of the box, you can use the cylinder. You can use the sphere. Okay, so things like that. So now, my question is with this: can we draw the shadow from that? Draw the shadow. So if you open up one of my file today, is Bone Study 2. If you select the Bone Study 2 and open up, I think, and it has a shadow behind. They have the shadow. So the shadow thing is a bit strange. It's very it's very simple in 3D software, but it's not so easy to doing that in particular this kind of 4B stuff. But there is the way we can do. Okay, so I'm not going to explain everything in here, but I want to show something. I want to explain something with one of these skull power examples. So if you go to skull power, and there is the shadow things. Shadow, and one is the shadow, the other one is the shadow fixed functions. So let's open up the shadow things and open up. Okay. So I'm gonna okay, and then if you deselect this help file, can't see that. Anybody has the problem with the shadow? Anybody has the problem with the shadow? What about you? Yeah. Okay. So why you? Interesting. Okay. If you look at this example, this node, I think it's the first time we see. Okay. And then another one. This one is another thing we seen it first time. Okay, so when 4B wanted to create a shadow, that means, as you can see, this health area, the orange area, and transparency box, they actually, with these kind of things, they create a textures like this, and then you need to overlap these images on top of this 3D structure. So in order to get these intersection images, we have to use perspective look at light. Okay, so that bit is this, health file things, orange things around the, half box, transparency box. Okay, so this one might be a little bit hard to understand. So today I just want to explain, introduce. In order to create the shadow in 4V, we need to create some kind of intersection images, and then we're going to overlap that intersection images on top of the target images. Okay? So just bear in mind, and then we're going to have a look how we can make the proper shadow in this Friday. Okay? Remember that shadow, cross-section images, okay? Overlap the cross-section images on top of the, the target area. Okay, that is how we can create the shadow things. Okay, and another interesting example is if you go to that Go Power again and click that slider project, and click that slider project, and click OK. You may not see that, but yeah, just try that. Okay. So now, in these examples, okay, we can use the same principle with this kind of examples. So imagine that this one is the wall as your target surface for the projection, and then you want to project some other images on top of that. Right? You can use pretty much this kind of method. So you need to create a map, images with that cross section, and then you overlap that cross section images on top of your target surface. Okay? So create cross section images, and then on top projection that images on top of that your target object. Okay, so this case, as you can see that this one is the same as before. They use that, and the other one is the project is textures. Okay, at this moment they are not belonging to that the normal node section, okay? But if you wanted to use, just simply click and copy and paste into your project. It might be perfectly working, okay? So we're gonna have a look this one, and the shadow things is for the next week, okay? Because it really will take time to explain that and properly, handling that kind of two specific nodes. Okay, so we're going to introduce this one next week. So we're going to close this one. Okay, now what we're going to do is we're going to do the video things. Okay, video things might be the simple and easy and fun. Okay, so for that, let's open up one of today's file, and the play video. Okay, so if you open up the play video, we have the video is playing at the moment. Right? And then in here, we get some color information from the scene, and I can make that spread. Alright? And then we continuously save this the sequence of images as the grid, and then we can display something like this. Alright, so, and a couple of other things. If you click that, there is another video, and which one is starting from the number. Can you select that one? And open up. It's working or not? Working is not. It's working? All right. So let's just start. So create new patches, video in. No video in. Video. What's going on here? Oh, yeah. Thanks. Sometimes I confuse myself. Videoing is, especially for that webcam kind of things. Okay, so if you type that file stream and dx9, okay, file stream dx9, and please save this one into today's folder, because we're going to use that asset. So video test. Okay, so file stream. File stream. And if you create the file stream node, the first pin is the play, and second pin is a loop, and third pin is loop start time, and the loop end time, and do seek, and the seek time, and the speed, and the last pin is which file you wanted to play. Okay? So, once you get ABI file, so they, at the moment, for B, in this particular case, for our file stream, only allowed to play ABI. Okay, so if you want to have, if you have the MOV file and PPOC file, you need to convert it into ABI file. Okay, so now, after that, they have the audio input, audio output, and the media output, and the video output, and duration, and position, and seeking, and another extra information. So now, what we're going to do is, let's create the video textures, and connecting to the video output to the video textures. and then create the code and use that code video texture and texture code code, and then we need renderer and connecting this renderer to there. Okay, and then uniform scale and 2. Okay, so far so good. Now create another toggle box and connecting this toggle box into the play, and toggle box. So now let's select the video. So video is inside of asset. So let's select this first one, starting from the 1862 blah blah blah. Okay, and once you're doing that, it's nothing. So if you play that, you can have the video. Wow, we have the video. Yeah, we have the nice video. Video. Okay, video. But at the moment there is no sound, right? So for the sound, what we have to do is we need to connect audio out, DX9, and connecting to the audio pin to the audio output.
I'm Lisa Frank, and for everyone who wants to know if I do exist, I do exist. I'm a real person. We're in my office in Tucson, Arizona.
And then you can have this.
What encompasses the world of Lisa Frank? That would first and foremost probably be rainbows, and then hearts, music notes, teddy bears, unicorns, stars, color, fantasy, jewels, glints, everything.
Yeah.
That makes a happy smile.
If you guys like, I can play one of those my movies or animations. Okay, anyway. So now, what we're gonna do is we're gonna try a couple of this pin, okay? Couple of this pin. At this moment, once they start, finish, they will stop. Okay? If you wanted to make a loop, what we have to do is we have to connect this duration pin directly to end time. Okay, so how we can connect? We need frame delay and connecting duration and connecting this pin to end time, and then we can have another toggle box here. So this one is a bit long, so let's change into the video, cartoon. That is a short one. Cartoon. And click the loop and play. Sometimes my one is not working. It's working? Oh yeah, not mine. It's working. So if you not play, just double click again and select the video. So that is the short film. So once you can see that they end, they will loop that again. But, yeah, I'm trying to find some pretty examples that is Okay, once they finish, come on, finish. Yep. So that they now is a hook. Okay. So next thing is do sit, which means they jump into the exact position you wanted to move in. Okay. And another one is the seek time. So you can, for example, if you have the 1 minute video, the video you can play start from 30 seconds, and then you must click that do sit 1, and then you need to provide information for where you start from. Okay, and next pin is speed. Okay, that is very interesting thing. Okay, so let's create that sliders. Okay, and then create 1, 2, 2. Okay, and show the sliders. So now is a very useful slider. Okay. Okay. So 1 to 2. Oh no, so 1 to 2. 0 to 1. Do you guys remember how we can create that button slider? Anyone know how we can create the button slider? Don't know vertical sliders? Anyone know vertical sliders? So what you have to do is change this option. SCX is vertical and Y is horizontal. Okay. So now we can have. Oops. Oh, sorry. Okay, yeah, forget about that. Okay, so make this one and connecting this pin to the speed. Yeah. So if you're connecting this pin to the speed, and then now you can control the speed, the fast and slow. Okay, so we can control the video speed. But you can't actually change the sound. Anyway, so that is playback the speed. So now what we can do with this? So that is very weight component. And if you type the textures split, Okay, texture split. And then connecting that video text image into the texture. Okay. They capture each scene and then tossing that each scene to this node, and then they conduct color analyzing, and then they provide RGB value. Yep. RGB value and alpha value as well. So now, as you can see there, how many slides there? 1, 2, 3, 4. Really many things. Okay. With textures, we can analyzing each scenes of the color value. So connecting this pin to the texture, and texture has the many different information. So we can have some kind of, if we go to the speculator, and spectacle, and then you can use the one of these things. Yeah. So let's select that bounds, okay, and then connecting this one to there, and then copy and connecting this one to there. And connecting this one to there, and then connecting this one to there. Okay. And with bounds, they calculate every information in that slice, and then they give you the width and the minimum and maximum. Okay? They give you minimum and maximum. We're going to use the maximum value to extract, assume what kind of the main color is going to be of each scene. So RGB joint, and then you can joint maximum, and the maximum. Okay, and now if you're connecting this one to color nodes, okay, we can see the color here. But the problem is RGB is sometimes it's really hard to control the hue value, because the hue itself is created in relation to our red and green and blue, right? So once you're connecting RGB color to this color node, and then after that, once you color split HSB, then you can have HSB value from there. So if you wanted to convert in the RGB color to the HSB, what you can do is with this color node, color IO box, and then it automatically change the HSB value. Okay, so now what I'm going to do is I'm going to connect this one to there, and saturation is maximum. And now you can see that this one is very strong color, this one is very weak color. Yep, but they have, you know, the belonging to the same color groups, right? And then if you want to, so with this we can create a strips. So let's some code and the renderer. And the transform. And Q color. So we're gonna contain 100 color. And connecting to the input there, and insert sector 1, and base spread 100 color. And then we can have the linear spread, connecting linear spread to X, and the 2, and then here is same as the 100, and then we can change the sign, so that's okay. So now this strip actually analyzing this scene and then provide, you know, the color information as the codes. So that is, you know, the color analyzing from that specific movie. So if you change the movie, it will different. Okay. And then okay, let's do the one more thing, and then we're gonna take a break. Okay, so in the same way we save the, you know, the color information like this. We can save, you know, the each scene of the images. So this time we're gonna use the Q EX textures. Yep, EX texture. And then we need another code and the renderer. And transform, connecting the transform, and we're gonna create a cross grid. So we can cross 2D and X and Y, and the linear spread, making to X and Y, and let's make 10. And then we're going to save each scene in this queue node. So connecting these video textures in here, and check the to insert one, and provide the counter number 100, because at the moment, you know, all of the code is 100 because it's 10 by 10, and then connecting this spread into there. So now we can have, you know, the video strip like this. Okay. So another way we can do is we can use, you know, the buffer. Okay, buffer spread, buffer EX9 texture. So one of these one, the queue actually, like, you know, the continuously update information, but buffer, you can create a little bit more than, you can use a little bit, you know, the different way. For example, if you wanted to save the scene images, if certain noise level or, you know, the audio, so if you wanted to save the images from very loud scene, then we can use, you know, the buffer. Okay, so for example, 100 count plus 10 count, and then index number and the counter, and output here, and the maximum is 100. Linear spread, another one, and connecting to the X, and this time is 10, and I'm gonna make this X smaller. And this Y smaller. Okay, something like that. Okay. So, and then I'm gonna create the bang here, and then select this one. Let's 10. No, you don't need to do that, just like to demonstrate something. Okay, so look at this. If you're connecting some kind of, you know, the audio analysis from this side, and then you can toss in that information here. So every time you want to bang, they will save the images. Where it's gone. Thank you. Yep. So they gonna, you know, they collect the images. Okay, so that is another way we can analyze in the video. So sound level, maybe the color value. So if you want to save some of the things like a red, this kind of the red color looking thing, you can connecting one of these things with the red value and compare is equal to the red, and then you can say the bang, and then they connect the strips of the information. So that is another way we can create use that video taste. Okay. So this kind of thing is very strong. So if you click that at the make the full screen, you can see that that kind of music is considered a really good value. So that things also sometimes we can make your animation itself as the video, right? And then instead of the play that we can play your saved animations, and then they creating something like this. It's very different. You can use them so much, everywhere you can use. Okay, so now let's take a break.